Good morning, friends. So, welcome to the series of Multiplexer. So, in this video, I'm going to tell you about the designing of multiplexer using the tabular form. Till last video, we have designed the multiplexer for the function AB plus C using 4 is to 1 mux, 8 is to 1 mux, and 2 is to 1 mux. But the technique was different simply to compare it with the standard representation of output of multiplexer. But in this, I will tell you about the tabular form. So first of all, I will see that we have three inputs A, B, and C. So out of three inputs, I am taking A, B as the select line and C as the input of multiplexer. So because for first case, I am going to implement this function using 4 is to 1 mux. First case, I am considering 4 is to 1 mux. So there are two inputs and two select lines and one input. So a table is like this. In this table, I have drawn two select lines in this particular side and inputs on this side. So for the combination of select lines, I have written A complement, B complement, A complement, B, AB complement, AB. In this fashion, corresponding values of these columns are I0, I1, I2, and I3, which are the inputs of multiplexer. And the inputs are written as C complement and C. So first of all, for this function, we have to find the minterms. A function which we have to implement using this multiplexer 4 is to 1. So the function is AB plus C. So for finding the minterms, we have to expand it in the canonical form, and the minterms will come here. Sum equal to minterm 1, 3, 5, 6, and 7. For this function, we have these minterms. So on the basis of these rows and columns, so first of all, we have to mention here the index number. So the index number will be what? In this, I will see that this is A complement, B complement, C complement. This is the index number 0. This is the index number 0. And this is the index number I naught, A naught, B, C naught. It is 2. So this is first index, second index, third index. On the basis of combinations of ABC, we will see that it is a 4, 5, 6, and 7. So these are the index numbers. And whatever the minterms we have, 1, 3, 5, 6, and 7, mark these all minterms in this table. So 1 and circle it, 3 and circle it, 5, 6, and 7. So for this particular column, only one is used, which is corresponding to C. So I will take C at I. From this column, we are using 3 only because 3 is present in main term, and this is corresponding to C. And from this particular C, and this is your 1. If both the rows are involved, means C complement plus C will be here, so it is a 1. From this particular values of input, I0 is corresponding to C, I1 is corresponding to C, and I2 is corresponding to C. So first three are C. 1, 2. So I0 is C, I1 is C, and I2 is C. And finally, I3 is 1. And these two are the select lines A and B. So using 4 is to 1 mux, this is the output. We can verify it if we are providing A complement, B complement, then we have C. Plus if we are providing A complement B, then we have C. If we are providing AB complement, then we have C as the input. And finally, for AB, we have 1 as the input. If we reduce it using this particular techniques, or we'll see the final answer is AB plus C. So the function we have implemented is coming again. So I can say this is the good design of implementation of AB plus C function using 4 is to 1 multiplexer. And in this case, we have selected select lines A, B. Out of all three variables A, B, C, we are selecting AB as the select line as C at the input terminal. And if we are selecting BC and last two variables out of ABC as the select lines and A as the input line, then what will be the case? So from second table, we will see that if BC is BC are using at in select lines and A is used at input line, then what will be the case? So first of all, we have to fill the index value. A complement, B complement, C complement. This is a 0 index value. This is the 1 index value, 2 index value, 3 index value, 4 index value, 5, 6, and 7 number index value. So now the first step is this. First of all, whatever select line, place horizontally on this side with the all combinations BC, B complement, C complement to BC, and in this particular rows we have to place A complement A. On the basis of this table, first of all, fill the index values. And now, what are the terms present in min terms? And circle these terms inside this particular table. So if I am not suppose, but we have 1, 3, 5, 6, and 7. So these are the min terms. So mark these min terms in this particular table. So 1 is here, 1, 3, 5, 6, and 7. So from it, we will see that at I naught, none of 0 and 4 are encircled. So here is 0. Both are encircled means we have 1. So only 6 and below row is encircled means A, and both are encircled means 1. So for designing part, if we have this particular type of MUX, 4:1 MUX, then I naught is coming as 0, I1 is coming as 1, I2 is coming as A, and I3 is coming as 1. BC are the select lines. BC are the select line. So this function will come AB plus C itself. You can verify it. So this is the design technique of multiplexer. Actually, we have three variables A, B, C, and it will be provided question. Then what are your select lines? If AB is the select line, then put C at the input side. If BC is the select line, then put A at the input side. Or can say I0 to I3, we have to put combinations, or can say form of A as input in this case. So these steps are these. First of all, we have to decide the select line. On the basis of select line, we have to put the select lines and inputs with all combinations in these columns and rows, and then mark the index values of table. In both the cases, we have seen the first mark the index value of table, and whatever the function you have to implement using this particular technique of tabular form, we have to find the min terms. And related to min terms, we encircle these values and then find the corresponding values of I0, I1, I2, and I3. And finally, design the multiplexer, put select lines here, and all the combination or the input variables at the I0, I1, I2, and I3. So this is the technique of designing. So the same function I will implement using 8:1 MUX in next video. So this is enough for this video. Thank you, friends.